In this video, I'm going to show you how to divide rational expressions. Okay. Now, if you haven't already seen the multiplying rational expressions, I really want you to view that video first because it will be really helpful when you go to divide rational expressions. Okay. The first step when you come across a division problem with fractions or these rational expressions is to rewrite the problem as a multiplication problem. Okay, and the steps to do that are to keep the first fraction the same, and then you're going to multiply by the reciprocal. Reciprocal just means we're going to flip the fraction. Sometimes, maybe from high school, you have the little phrase like keep, change, change, or keep, change, flip. However you want to memorize that part is fine. But we're going to keep this first fraction as is, same position. But then we're going to take the denominator of the second fraction, put that as the numerator, and then put the numerator as the denominator. So that's the first thing we're going to do with this problem. The second is what we're going to do is we're going to factor each of the parts of this problem as well, because we can't multiply or start to simplify until we break these larger expressions up. And so to save time, I'm going to do both of those steps at the same time. I'm going to factor and flip the second fraction all at once. So here goes. As for the first fraction, it's staying the same. When you factor x squared plus 3x minus 27, it factors into two parentheses. X's go here. Two numbers that multiply to negative 28 and add to positive 3 would be a positive 7 and negative 4. The bottom expression, two numbers that multiply to 4 and add to 4, is 2 and 2. X plus 2. All right. So for this next one, I'm going to go ahead and change the operation to multiplication. And now we're going to flip that second expression and factor it at the same time. Okay, so the original numerator was x squared minus 49. That's a difference of square. I'm going to put the factored answer on the bottom, or in the denominator is the right terminology. And then x squared minus 15 minus 14, I'm going to factor that and write it across the top. That would be x minus 7 and then x plus 2. Okay, now you are ready to start simplifying these expressions. So we have factored, we have flipped the second fraction, and now if you see an expression that has a match in the denominator, then you can cross that out. And so if I start here with the x plus 7, there's an x plus 7 here in the denominator. Next, let's see, there's an x plus 2, and that's going to be crossed with just one of the x plus 2s. You can't cross out both of them. And then there's an x minus 7 gets crossed out. And that looks like it's it, guys. We're just left with the x minus 4, and so it's up to you. If you want to keep the parentheses around it, you can. I don't require my students to, so you can just list it x minus 4 over, and then there's just an x plus 2. Okay, now this is your final answer, but I want you to take a look at this. Even though there's both variable x right there, you cannot cancel that out because that x in the numerator is connected to the negative 4, and the denominator x is connected to the positive 2. So we're not exactly sure what the exact value of the numerator is and what the value of the denominator is. And so since we're not sure, we just have to leave it as is. And so the answer is x minus 4 over x plus 2. Okay, guys. Take a look at this second example. We're dividing fractions, dividing rational expressions here, And the key to get started here is to multiply by the reciprocal. We factored in the previous problem, but because this is an example where there's just coefficients and variables, there is no need to factor. And so what we will do is I want you to take a moment and I want you to go ahead and rewrite this problem as a multiplication problem. Now it's really tempting, and some of my students do this, and some can do it well and some can't do it well at all. They try to pretend, okay, the 16 is really the numerator one, and they try to cancel it, and it doesn't work very often. And so take just a few seconds and go ahead and rewrite the fraction. I think you'll appreciate it after you do it. Okay, so from here, I want you, let's first focus on the coefficients. We'll simplify those, and then we'll do variable A's and then variable B. Okay. If you take a look, I'm going to go diagonal here because I see this 24 and this 12, and I know that goes into 24 twice, and I can cancel all of that 12 out. And same thing with the 16 and 8. Now you didn't have to go diagonal. You could have simplified the 16 and 12 as well, and it would eventually work out to be the same as my answer. Okay, that looks good. Okay, let's look at your A's. The way I want you to imagine this is I want you to find the total number of A's for the numerator and the total number of A's in the denominator. And how you find the total is by adding the exponents. And so if there's 4 here and 3 here, we have a total of 7 and a total of 3 in the denominator. So we can only take 3 A's from the numerator and from the denominator. That crosses out all of the A's in the denominator. And since this one is already A cubed, I'm going to just cross this one out. And that leaves us with this A to the 4th, okay? Across the top, we have 3 B's and 4 B's in the denominator. So there's 1 extra B in the denominator. So we're going to cross out the B's from the numerator and just this B3. That leaves us our extra B. Okay, now we're going to just put together what we have left over. We have this 2. We have the A to the 4th, and then we have this 2. So that looks like 4A to the 4th. And then we have these 1s, but we don't really have to multiply by them. We have this B and this 1. So really we can just put the B. And then I do want you to take just a quick look and just make sure you didn't accidentally leave out a common factor. But I think in this case we're all right. So your final answer is 4A to the 4th over B. Your turn. Pause the video and work on some of these problems on your own.